Good evening, everyone. My pleasure to welcome you all to the Recal Alumni Expert Series, talk number 4. Uh, I am Madhivanan, the Vice President of Recal, and today we are delighted to have with us our senior alumnus, Dr. Anup Saxena, Mechanical Engineering, batch of 1985, an experienced professional in plant equipment management and asset management and reliability. He will share his valuable industry insights on plant and equipment management, building the RCM foundation for Industry 5.0 and Maintenance 4.0, along with his perspectives on career opportunities and future skills. On behalf of RECAL, the Alumni Association of REC NIT Trichy, I extend a warm welcome and sincere thanks to Dr. Anup Saxena and for sparing his valuable time and expertise with us. Dr. Anup will be introduced by one of our fellow alumnus, Dr. Blesto. I thought it's also fitting to give a very brief introduction to Dr. Blesto as well. Dr. Blesto is currently working as the Dean of Academics at Maria College of Engineering and Technology in Kanyakumari. He is a proud NIT Trichy alumnus from the Metallurgical Department, where he earned his PhD, followed with postdoctoral research at IIT Bombay. His scientific research focuses on the strength and fracture behavior of specialized nanosteels and aluminum alloys used in space shuttle tanks, resulting in over 15 published papers in highly respected SEI and index journals. Over to you, Dr. Blesto, to introduce our speaker, Dr. Anup Saxena.
Thank you, sir. Good evening, everyone. It is my privilege to introduce our distinguished speaker for today's Recall Alumni Expert Series, Mr. Anup Saxena, a proud alumnus of REC NIT Trichy, Bachelor's in Mechanical Engineering 1985 batch, is an experienced professional with extensive expertise in plant and equipment management, reliability-centered maintenance, asset management, and maintenance strategies. Through his rich industry experience, Mr. Saxena has contributed significantly to improving plant reliability, equipment performance, and maintenance practices while adapting to the evolving needs of the modern industry. Today, he will share his valuable insights on plant and equipment management, building the RCM foundation for Industry 5.0 and maintenance 4.0, focusing on the changing industrial landscape, future skills, and career opportunities also. We are truly pleased to have him with us and looking forward to an engaging and insightful session. Ladies and gentlemen, please join me in welcoming Mr. Anup Saxena. Thank you.
Thank you, Dr. Blisso, for introducing me, and
Yeah.
Dr. Madhavan.
Sir, you can take over the session, sir.
Yeah. Good evening and good morning. I welcome all the delegates today. A very interesting topic, which is directly linked with the current scenario worldwide. I hope all the participant delegates will be benefited by my experience sharing of last 4 decades on the subject. I am already being introduced. Only the profile 2 points I would like to stress is, one is whatever I'm going to talk is being practiced in the plant and senior position by me, and along with the consultation and advisor to the different industries and different seminars. So in the profile, I have worked around 25 years in industry, and the rest is in the 15 years in the consultancy and training. So this presentation will be in basically on 4 parts. One in industry advancement, RCM foundation strategy for the industry 5.0, one case study, and we'll be concentrating on the career opportunity and learning on the subject what we're going to discuss. The first thing for all the audience and delegates, I would like to say, this slide is saying many people may be aware what the asset diagnostic RCM based for maintenance 4.0. Not to worry, but if I know everything, then we will not go ahead. But at the end of the presentation, I hope there will be more insight, enlightenment on the content. So this is basically required. We have to continue to learn for the new knowledge, new skill in any technological innovations. This is very well known from 1784 how Industry 1.0, where mechanization was there, and then it moved to the Industry 5.0. What we are seeing over here is from 2010 to 2020, and within 10 years, there is a leap in the technology very fast. Otherwise, you see other one is 100 years of gap of each of the revolutions which had taken place. And what we are seeing in the photograph is a smart factory, automations, people are analyzing at their offices, operating the plant from this. So what we are going to see is the lot of AI interference. What we need from human base, it is going to be diverted to the all automations and other aspects, which is a big challenge for India. Because we at only a 5% we are trying to implement this Industry 4.0 and 5.0. And next 10 years is going to be very vital. People have to change their style and get into the latest what is coming up worldwide. So this is like this. 100 years we have using the water stream for manufacturing processes, electrical technology came, then the first computer era, and the people went to moon, and then digital transformation in 2020, and now we are in the Industry 5.0. Basically for the industry, there are around 10 modules which are applicable for the Industry 5.0 and maintenance 4.0. The vital here is the people in India is starting in the predictive maintenance module. Many are going to process optimization, then quality, energy efficiencies, product development, safety improvement. So what we are trying to say is going to be a big work which is to be done by us to be competitive in the competition. Otherwise, we'll be lag behind, and these are going to be very fast. Within 5 years, we are going to have the all 11 modules. 10 models going to be implemented, and many companies are doing, but not to the great extent, particularly in developing countries. They have started just predictive maintenance, process optimization, but we have to go for the best system. Let us see what are the challenges. What challenges we face anywhere? The high cost of scaling. We don't have resources to that extent. Data analytical is not that for the all the people who are concerned with O&M, quality, and processes are very complex. So we require the expertise. Machine learning is the presently weakest link for the AI and smart sensors. And then what is main concern is the artificial intelligence versus human intelligence. There's a big fight, big discussions going on. But we will see that both are complementary to each other, because human intelligence cannot remember all the things, but the artificial intelligence can have the vast amount of diagnostics, and human have to finally take a decision of 5% what is right and what is not right. That's why it is called artificial, and we have to actually human is always vital. So this is to be concerned. So big what challenges what we have, and we have to resolve this at the earliest. So now coming to the many companies worldwide, the vendors, they have very good smart sensors and AI software. What we lack is machine domain, machine learning, because this is the always with the manufacturing plant. They are the expert in particular, say, rolling mills, power plant, the turbines, maybe in chemical plant, petroleum industry. So what we lack is, when we implemented this, the sensors were put, software is giving report, but the expertise on machine domain is, so there's a big subject which is to be made it perfect, and where the RCM comes, reliability centered maintenance, which is a bridging gap between AI software and the smart sensor. Unless we make the ML strong, we are not going to land up anywhere to have a successful system, because it's going to be very costly systems. So we need to focus on this to get the best from the system what is coming up in different industries. Why it is important, machine learning? What we have is in the plant, any industry, it is not only mechanical part, electrical part, or operation part. There are many interactions, like person is operating, quality plays a role, and process interaction. We have to combine all these interactions to make a good system. Let's see how it goes. For example, fan and blower, I take an example because it's a simple one. Everyone knows about it. Even in instruments also, they have in the laboratories. Plant is always there. Anywhere it is there. So what are the system variants? We have air, wind, pressure, flow, and vibration. And what are the defects we are trying to capture? Maybe aerodynamic forces, unbalanced alignment. And we require the monitoring techniques of different smart sensor that comes and works. Maybe certain and offline. So it's very important what we are intending to do from this is only one part of the equipment in the 500 thousands of equipment are in the plant. We have to see what if we are interested to get the defect capturing and how we're going to put up in our smart sensor, AI, and machine learning. There are different type of monitoring tools which are being automated nowadays, and which can be directly coming into Wi-Fi and other things through your mobiles, computers. Wherever you're in the world, you will know how a machine is performing. Now, what should we do for making it the best system? We have the multi-parameters smart sensors, but we have data from DCS and PLCs. We condition health assessment parameters. We require the integrated approach where we have the plant maintenance, inspections, SOPs, and trainings. Then develop a reliability health index, which will be backbone of the machine learning, which is to be incorporated for the smart sensors interaction and making the SI give the best results. Then we have designed a global assessment matrix, so we know what we intended from the equipment, and identify the what we gain out of the systems. And out of this, is very important to plan system planning, selection for implementation. After going through this cycle for the study, if we don't do this through this, there is a probable chance of some pitfall, not giving the desired results. So this is a matrix which is being developed for an asset. I'll devote a little bit time on this. So we had to list down the critical equipment. Total plant is not in problem. 20% equipment gives a problem, not 100% equipment. So list down those equipment, and if you are having the offline, online, whatever it is, what is the condition monitoring or the risk-based instructions, present test status, maybe vibration, maybe thermal profile, maybe wear particles, maybe your anti-flow turbulence leakages, and maybe electrical parameters. So you just have to write the okay, not okay, and detailed annexure will be there to have that. This will be should be on the table of the plant head, HODs, and there's a backbone for the making the machine learning database for the system when we are going for the industry 5.0 and then we have certain vital link from the shutdowns. That is very important on physical verification, how it looks, maybe you can visuals. Preventive maintenance, what we do in the plant during a stoppage and running. Inspections. Then we say about the basic condition of the equipment. If the equipment is in good condition, the plant is in good condition, housekeeping part, and then the different audits. And the SOPs, standard operating procedures. Maybe the asset management 55001, what is the status, whether it's implementable or not, and then turning on the health index. This sheet is very important. The plant people should have this, and the student also should start thinking about this. These are the subjects which are going to help them in making the career. We'll see discuss on that later. But let's make this, and it becomes a very important data for the machine learning and making a bridge for the installing the sensors or maybe monitoring and AI getting best out of sensors and the machine learning. Then we have developed another parameter which is called as a machine health index. It is based on the different parameters, and we design the scales with the starting with 5 highest, excellent, very good. Or for this, the weightage to be given for a particular parameter, how important it is, and accordingly, excuse me, accordingly we say whether our motor is all right, gearbox is all right, or the plant process is all right. Not this is not only for mechanical part; it's operation parameter also will come. Quality parameters will also come. Let's take an example. For example, you got turbine. There may be different parameters. I have narrated only few. Maybe axial displacement, radial vibration. Slightly technical, so need not worry. What I'm trying to say is, with that we can say the gearbox, what is vital, pump, water waiter, the oil circuit for this for a particular plant example, the different units, measure in displacement, mills, temperature, then the vibration unit, then the oil circuit pressure. Their ranges, the weightage is given for different parameters. 4 is high, 5 is highest for the gearbox, and for very good given 1, 2, 3, 4. It can be excellent scale also. So if the less than 7, it is good. What you are seeing in the yellow background is the current position when it's running. And depending on that, when you multiply, for example, 5 into the casing vibration, it is running at 3, between 3 and 5. So 5 into 3, you get 15 marks. Similarly, for axial displacement turbine, 4 into 3, you get 12 marks. When the maximum point you can get is 164, and we are getting 102 after seeing the different multiplication and where it is presently running. So we get the reliability of this particular health index of this particular 62%, which is very low, and we have to bring the warning portion, for example, signature analysis, peaks, body temperature, gearbox weight, bring it back to the 4 scale of very good or 3 by doing the work on the system to improve this, so that we can say. Similarly, you can have to develop for those 20 critical equipment, and it becomes a ranges for the AI, artificial intelligence software, and along with the sensors can be calibrated on this. Now, I would like to have a brief queries, clarification, discussion, what we have covered till that particular slide of this and this. So I ask the people to have a little bit discussion. Otherwise, only I will be continuing this presentation.
Yeah. So I think if people who would want to have some further information on the slides Dr. Anup has run through so far, if you want to raise some questions or clarification or even discussion points, you are free to bring it up. Either you can raise your hand. I think there is a this thing. You can raise your hand and we'll unmute, and then you can go ahead with your question or your discussion point.
Maybe in chat somebody can read the question if it has come in the chat.
Yeah. You can either post your questions on the chat or you can raise your hand, react. Yeah, okay. Ravi Subramaniam wants to raise a point. Yeah, Ravi, you are unmuted.
Yeah, sure. Okay. Thank you very much. And Anup, thank you very much for, very good introduction to the topic and your slides as well. Very informative. Really appreciate that. I just wanted to connect it back to...
You're from the batch of?
Thank you, Ravi.
Yourself with
I am Anup. I am Anup, same batch. So we are, I think, in the same year, 1985. Yeah.
Okay.
So actually, I was maybe you'll be covering it in the coming slides. Maybe I'm asking ahead of time. So how do you connect all this to anomaly detection? And for example, for maintenance, right? So preventive maintenance and uh, ability to determine which machinery part is going to go bad and taking an early look at it, kind of thing. So you might be covering it, but I just wanted to bring that up. So.
Okay. Presently, what is happening is the condition monitoring software and the software are having different platforms. So what we are trying to have the integration from the DCS signals, PLC signals for the operation parameters, and condition monitoring. We have the online sensors nowadays, plus the PMPI and the shutdown data which are coming in the SAP. So that is being quantified now on the scale, like we have the condition monitoring ranges. Similarly, we can put up the ranges for wear out, for example, and give a range 3 for the belt wear out, for example. And for that rating, you can give a 5 for excellent. There is no wear on the belt. So, for example, that is to be quantified and given a unique code for that, and then integrate with the global AI software. So that works. But it takes time. Yeah.
Okay.
No, thank you. Yeah. Anything else? Yeah.
Yeah, I think as of now we are fine. I think you can continue, Dr. Anu.
Okay. Thank you, sir. Now, what we should do after doing this, developing the metrics, developing health index. Now we have to discuss with the many vendors are there, particularly when we worked in a steel plant. So they come, their system is very good, very nice, and AI is very good. Smart sensors are excellent. So it is to be done a comparative feasibility study with the vendors, maybe Siemens, maybe Symphony, maybe Simcon. And based on that, we have to first see the compatibility. Cost also is very important. ROE is going to be asked, and find out which suit best to the organization. And what we find, to frankly share with you, the sensors which we have installed in Simcon, some company, it malfunctioned during shutdowns and during some deviation of the operation parameters. So we have to go for a very robust and very strong sensor, so that in remote areas it doesn't give the anomalous readings. So many times, like in crane, if you put up a sensor, it always vibrates. Whenever it moves, the sensor shows alarms. So we have to give some pause when it is for a certain time, and maybe 30 seconds. Then that particular signal should be bypassed. That is very important. And second point is, if the machine is not good, machine basic condition in a sense, cleaning is not there, inspections are not all right, bolts are not in good conditions, lubrication system is in bad shape, and is giving an abnormal sound, so it will not work. This hi-fi system will not work, because already machine is in the deteriorated stage. You have to bring the machine to the commissioning stage, when the machine was taken new. That time, the best condition of alignment, best condition of bearings, best condition of the gear, whatever it is, the motor. So all that parameters should be all right. Work on the health index, and see the machine learning link with the history, and finally do the interaction with the interface with the maintenance 4.0 and Industry 5.0, and required to go for multi-parameter smart sensor. Why I'm saying this? All machines do not fail because of vibration or mechanical reason or temperature. It is a combination of technique which we saw in the slide. There is a process interaction, machine interaction, quality interaction. So we have to combine all together and get the range, and then decide that with the assessment metrics, and globally we can how can we predict machine real status, and with the objective of ensuring availability, and with the no surprise failure or zero breakdowns. So we choose 50 critical equipment in a plant and set up the ranges for normal warning alarms, collected the basic data which are required for identification, and installed in the different plants, 5 places. We have 10 divisions, for power plants, rolling mills, pellet, and other places, DRI, steel melting shops. And we got the cases after 6 months of struggle to get the AI work as per the machine real dynamic at the shop floor. So we continue to modify the findings of those software. So this is where we installed the sensor. This is one of the TMT mills which are used for the building construction, the rods. So we installed different the steel plant where the rolling mills are there. So around 34 sensors in the structure mill, 48 sensors in TMT, and these are wherever you are seeing the bright shiny. Those are the control panels over there, and the sensors are on the equipment. The light blue one, what you are seeing is the sensor. This is the signal capturing through and from there the Wi-Fi and to computer network. And so there is one case study where the one of the important part of that tail breaker machine, which goes because offline was not working. Offline means you will find immediate health, but when we put this sensor and the online diagnostic in the like a traffic signals, you will get the all displays, and immediately at your home also midnight you will know the which machine is outgoing out of way, so you can sleep well. I understand only few machines are troubling. So what we found out in that is the gearbox was having difficulty in tail breaker, and it is a problem in the input teeth, and how the amplitude was varying. People may not be knowing the vibration field, but those who knows how it goes up. Then you got the ECG of the machine, critical signature analysis, which will tell us see what is the defect coming in the machine. Here you add a lot of expertise. So we could there were the two reports, one from the system, and other one the system was given 4 3 options, and other was the here the human intelligence come. Now you have to choose which is best as per your machine working and operation conditions, because that way AI will give you short suggestions. These are the fault. Maybe they may say bearing is defective, gear is defective, or alignment is a problem. But you have to choose from your shop floor experience which is the best suited for that. And of course, the offline if you are doing, then those signature analysis, your expertise plays a role. So human intelligence is always vital for this. And it's a very this is one of the case studies. Many case studies are there, but we have to discuss about the other aspect in the presentation. So I'll just share this. And what we got from this, earlier we had around 1364 minutes failure total in 205 days, and delay per day were 12.99 minutes, and it was brought back to the around 2.05 minutes per day, and total and lot of savings. So only by within 1 month we could save the cost of the installation of the rental cost and system maintenance 4.0 and 4.0 in the system. And if you get 2.10 lakhs in Indian rupees in 1 month, and if you can avoid even 5 failure in one division, I'm telling you about one division. There are 10 divisions. There are 50 failures if you can avoid, surprise failures, which there is no even intervention. Online it is coming everything. I can say if it is implemented correctly, then you can only save the cost of the system, which is costly, and you have to convince the management, top management, it works if it is properly designed. So what again additional gain we got it from his deeper process and machine learning, because which were not hidden, and we could increase the machine reliability, assessment to 24/7, no human intervention. You can also not only equipment monitoring or the process monitoring, you can save a safety point of view, quality point of view, and rightly you can utilize the manpower which is engaging for the machine monitoring. You can optimize and distribute somewhere else for a more productive job. And detailed data, keep eye on the system analysis. There is no hide and seek. People cannot say machine is okay if it is not okay. The system is telling you whether it is okay or it is not okay. Now, coming to the my REC team, the students, academics, and this, there is a big potential for the career development and the learning in this subject. Why?
Dr. Anup, just a small saying there are a couple of questions. Can we take these questions before we move on to the?
All right, it's okay.
Yeah. Okay.
Yeah, please.
Yeah.
Yeah.
You can keep the slide. Yeah. Okay.
Okay.
Sir, shall I read out the questions?
Yeah, you can. Okay.
Yeah. So can you share the percentage reduction in main cost of the plant by switching to or introducing the maintenance 4.0 compared to previous systems used? Anup, sir?
Yeah, which slide?
Not the slide, the question.
Yeah, what is the question?
Can you share the percentage reduction in maintenance cost of the plant by switching to or introducing the maintenance 4.0 compared to previous systems used?
I can assure if you have even if you have the no failures in the plant, or very good maintenance system, ability very good. But there are many surprises in the plant, like in a petroleum plant or any fertilizer plant or power plant, which in 1 year, one failure can immediately bring the law into the losses. At least 30% of saving is easily can be done by this setup. But things should be, machine learning part should be very, very good. And what I am trying to say, it is not only prediction of failure avoidance. What we are working on is the machine life enhancement. How much life is remaining? What is the wear rate? What is deterioration taking place? So please don't look at this maintenance 4.0 and industry 5.0 only one aspect of avoiding the breakdowns or reducing the maintenance costs. Maintenance cost will become any why equipment life cycle cost. We want to run it for 30 years. A gearbox should run for 50,000 hours without any problem in that. Or motor should run for 80,000 hours. So in between, this system will. We are not talking about 2 months, 1 year. We're talking about 4 to 5 years, and machine can be very well in control if we have the system with us, because human have a limitation. You cannot remember all of it, and the fact remains. If you are at the shop floor, people who worked in the industry, they don't have time to get the entry done properly, and sometimes we miss vital things. So I think 25 to 30% is easily we can save with a longer perspective. Does it answer?
Yeah, we can move on to the next question.
So Justin, sir. So he has asked, so what kind of ML was used? Is it computer vision?
What kind of?
ML.
Machine learning.
Yeah.
Machine learning. Yeah. You're talking about the software part or the
software part.
Integration part?
Software part.
See, the people who are at the shop floor or the manufacturing area, they will be building up the ML, but the software part will be covered by the vendor, which is best suited to them, to that particular. The initial for machine learning and the detailing in that, that is well understood by the people in the plant. So what they have done is they have inbuilt this ML in the AI. The input which was given by the plant of the basic data, but that is not sufficient. So we have to integrate the maybe smart SAP into the system if we want to cover the 11 models, 10 models in that, having the, for example, product development, logistics, research and development data, process optimization. If you want to do the globally, then that particular integration is required. For software, exactly, I cannot say, because Symphony has different software in that. Your Siemens has different, Tata consultancy has different. So maybe the we had the Simcon ML system and the smart sensor and AI. Yes, sir.
Okay, sir. Also, subsequent, also have a follow-up question. You said for ML it took 6 months. but ROI you got within 1 month. So I would like to know the exact lifespan for the whole exercise of this Industry 5.0. Is it only ML that was done in this particular case study, or is it some other things like you said? Because I think SAP integration, everything would have happened as you just mentioned. So this ROI starts after 6 months, or I wanted to know the exact lifespan.
Actually, this system, what is being we are discussing, it is not the only role of the smart sensors or the AI. The plant has been kept, and they are doing some of the world best practices. That is called as a implementation of reliability-centered maintenance, total productive maintenance. So machine's basic condition are already good. On top of it, this condition monitoring, they had in-house a very strong system. So what we're trying to avoid with this maintenance 4.0 is the surprise failure which we are not able to capture through the system what we had. But you are rightly saying the 9 months is minimum for the ROI. But we got immediately because that particular machine was very depending on the product quality and the temperature variance of the billet which goes into the mill. And there is a sudden load changes and the effect of the cooling and heating phenomena, which damages the particular machine, which we are not able to capture with the offline monitoring which we had in the plant. So 9 months is minimum. 9 months is minimum, and we have to project not by, again I am saying, not by the breakdown saving actually only. What we have to say is you are able to predict the machine health, and you can plan the annual shutdown. The shutdown, which is a big issue in petroleum plant, fertilizer plant, you can extend it or get it cost effective by extending it from 2 years to 3 years by continuously monitoring through the system. Yes.
Okay, just to get a comprehensive view, this ROI for 9 months is for how many kinds of, you said some mills, equipments like motors or whatever example you said, bearings. So ROI for how much number of equipments is 9 months?
I only say you take only 20% equipment, not 100% equipment.
Okay.
Okay, 20% equipment, because 100% all equipment are not bad. 80% are good.
Okay.
They are inherent reliability. We will do it slowly for them also, but initially target should be our 20%, which are troubling us as per the history from time to time.
Okay.
Right?
We have one more question.
Yes, sir.
Sir, I have one question to ask. Can I ask, sir?
Yes.
I'm Sridhar, sir.
Yeah, Mr. Sridhar.
Yes.
Sir, I am from a power plant. I would like to know that in these diagnosis, suppose if there is a abnormality detected, how is the diagnostic person coming into effect, sir? Like I would say that you detect that there is a problem in a gearbox or maybe in a transmission. But how will you really focus upon whether it is coming to a foundation or whether it is a looseness, whether it is alignment, whether it is a bearing or whether it is oil? How is that being generated? And in the absence of that taking a shutdown is very, very difficult because people don't know where to focus. This is one thing which is making people to delay the decision. And also they feel that information is not so fruitful in taking a decision. This is a real situation in the field, sir.
Thank you, Sridhar. I'll answer in two parts. One is the turbine and other gearboxes on the very high, costly and critical equipment. They already have a protection device in the control rooms. So they protect whenever anything goes high, turbine will trip and machine will be saved. But coming to your point, these sensors, whatever you have put in the system, through AI diagnosis, you get a signature analysis. Signature means we will know for a gearbox, the gear is there, getting deteriorated. You will get certain parameters which comes under the vibration velocity or the acceleration, and it will get the gear frequency, and along with the metallic sound which is coming through the ultrasound, the separate technique. So expertise required in the condition monitoring and the ultrasonic to know exactly the fault in the internal system, whether it is coming from gear or from the bearing or the shaft. So that is very well possible. I am in this field for many years on condition monitoring, and expertise of course matters, because only software will give you some signatures, but we have to analyze, like doctor analyze the ECG. So you'll say whether your heart is working well or not, or what is the defect and the valve is all right or not. Similarly, in the gearbox, turbine, rotor, we have to have a correlation of the vibration with the operation parameter, loading and unloading, and what frequency turbine is running. So it is possible. We have done it. We have done for many 220 megawatt plants, the small captive power plant, and it is 100% accurate in diagnosis. Thank you. Yeah.
Okay. Yeah, one more question I think is there from Dr. Blisto. What is the most suitable data intelligence and visual workflow platform software for the smart sensors?
Can you suggest the software or the vendors that they are providing software?
Okay, what we have experienced with the one of my associates who are in this system management. The Symphony is better. The sensors are very good. The software is very good. It takes care of that is a very powerful software, and the powerful sensors don't go very bad, but very costly. They have installed in the plant nearby in SAIL, one of the company in Vanpur, a steel plant, and it is giving a fantastic result in blast furnace, the steel plant again, and power plant. So Symphony seems to be good, but people in India, I have also worked in senior positions, so I understand the people from the day one, they will ask you ROI. So if you invest around 2 crores of rupees in Indian rupees, the management will not wait for 9 months or 6 months. They want immediate, because they don't understand the consequences, which is better, which is not. What I'll just narrate, I don't want to say any vendor's favor. Some of the very good companies, they have taken something from some companies in India, but now they are not getting results. The AI is giving false environment settings. Smart sensors are not giving live. So they have burned their finger by the cheaper option. So it's always say buy a better software and better system rather than going for cheap option, because you have to double the expense. You have to do it later, because people will lose the faith. People lose the faith in the system. So I ask senior management, other people, learned people like you, invest once and get the result out of which. Maybe you do it for 5 equipment, but do the best. Because we, for the order purpose, people are taking order, getting funded from some other overseas for something, but it's not giving life in India. So we again, for India, it was a new concept 5 years back. So people got not the best value what they have invested, and now people have become more learned. Now they are asking the vendors and they're blacklisting the people who are given the cheaper option and not given the results. Right, sir?
Thanks. Dr. Anup, we can proceed with the slide now.
Okay. So as we see like you see in 1990s, when the computer come in the bank, that many people are saying we will not change. Like ATMs were not. Now everybody is doing, nobody going to bank and all that. Similarly, please understand, any industry, whatever old system they are doing, they have no option but to change. And next 10 years, the potential for the academic, student, industry, leaders, the system is going to work. Because when you talk about Prime Minister, anyone they're talking about digitization, AI, without understanding what is going to give. To that extent, what we technocrat understand. So this is maybe word of mouth. This the people will say, my neighbor is having a smart factory, why not we? So it is going to become, and is people are shortage. There are not trained people in this. People don't have any advanced training on this. The academics and collaboration with the vendors, industries, those who are doing this R&D projects, do the subject, take the subject, machine learning, AIs, smart sensors, and work on the field of predictive maintenance, process optimization, this area which are given to you, market analysis, research and development is a potential area for the students, for the engineers, postgraduates, PhDs, and they're going to have a big market. I'm not talking about coding and all that. Coding is a different aspect of AI that is already flooded. But the machine learning part is still in demand. And to revive the industry to the best of technology, these are the potential areas which are going to come, whether you believe it or not. Let us say in the next 2-3 years, you yourself will say, yes, this is a need of time. And there is a scope for people to get it ready for that fast on this. And we have guided people on the subject, what experience I have got in this system to become ready for that. And people give you some examples, some GTs joined from NITs, and they were training in condition monitoring and the plant management, RCM, they got now in the online sensor, they moved to this side what we are discussing about this. So rest assured, the potential, the time is for that only. And if you don't back up now, it will be late. It will be late, and half knowledge is not good. Don't take certificate from here and there. Do the in-depth, detailed expertise, which can be useful to the vendors, to the technology, to the even the colleges can set up the lab on this as a pilot models areas, this, and show the demos, and during interviews and your interaction, entry type interview, you can be successful if you have expertise. And condition monitoring is one of the subject which came there. AI plays a directly role, risk management, fitness to service, all that subjects are very important.
Dr. Anup, I think can we take some questions from the students? Are there students here who would want to raise questions? Have a question in your mind?
Yeah, I have no problem, but we don't run out of time for other people, other delegates.
Yeah. So students, if there are students who want to get something clarified on the manufacturing industry side, you can, this is the opportunity for you to bring it up.
I am audible, sir?
Yeah, Anil Kumar, yes, go ahead.
Yeah, sir. I'm a student, but I am working in the automotive industry the last 2 years, mostly grains and powder. So I see a lot of preventive maintenance also. So I also.
Your voice is feeble.
I'm audible now?
Yeah, audible but feeble.
Just a minute, sir.
Okay, continue.
Hello.
Yeah, please. Yes, better.
Audible. Sir, I just working as a automotive industry as my GT first. So also I working as a service engineer in automation, SPM machine, special purpose machine.
Okay.
So I go through like sensor also, but I'm still like see the preventive maintenance because I go there as a mostly I've done technician work in last 1 year. So we call the on site during the installation or commissioning. So we see there is a lot of operator and there are maintenance team. They don't understand much. There is a new technology. There are a lot of industries going on there. So how do we like to make these things like to be easy and stable, to understand they have to be maintained, to be machine health, you have mentioned like that. And also I also be like need guidance, like how do we go through this to understand more this industry that within 10 years is really booming. So can you give me insight like how I just pursue this?
See, the first part answer is if they don't go with the time, they will vanish from the scenario. Okay, because automotive industry or any industry won't wait for people to live in the same stride. Okay, so they have to see these systems what we have been discussing now, RCM, the CBM, RBI, risk-based inspections, AI, smart sensor, this. Because people don't want people in the shop floor. They want a smart factory, automatic diagnosis. So expert will be required, like I have shown you the first slide, where the people was in the control room. They're monitoring the entire factory. So they have to move to diagnostics, data analytic, understand the machine behavior through these signals. And problem here is this one slide which I showed you, when people say I know everything, they stop learning. So the case in your case, your people case is, they might be thinking, okay, I have heard about smart sensor, I have heard about this, I know everything. But when they go to the lectures like this, or some educate them and do it in the, not entire plant, do it in 2-3 equipment and demonstrate it works, because there is a fear. What fear is there? If it works, then where will I go? So they have to be with the time and practice on this. And okay, now the question which I asked you, last question, the career opportunities and this change management is the psychological. People have to tune their mind, there is no other go. You are already seeing what the big industries say, engineers are not employable because they do not have the gap filled with the industry and the academics. Why they say, many people will say, because we lack this type of latest technology, the practical aspect, and the people they are not useful in the plant when they join as a GT. Your case might be different, I don't say that, but very difficult. Students have to tighten their belt and learn the you have to be best among the lot available and do with the time. Right, sir?
Yeah. Thanks, Dr. Anup. Yeah, there is a poll which is posted there on the chat window. I request folks to alumni to fill in the poll.
Okay, sir, I'll just complete 2 more slides.
Yeah, okay. Please go ahead.
So we got the case studies, large savings, and we established machine learning for 50 equipment, critical equipments. And lastly, we express our thanks to the RCM for giving me opportunity on plant equipment management and the patience of the delegates to go through this difficult particular subject. And we have taken reference from the Siemens and Symphony and other vendors making this presentation with as a part of my decade of experience in this field. Thank you very much. And my contact details is being mentioned in the slide, and I would share with you the PDF copy with the RCM, and they may pass on to you, and you can utilize. And I wish all of you to have a successful in these new ventures, new things, and spread this message to your colleagues and in industry, and make India proud to one of the leading country in this AI, smart sensors and machine learning, and implement instead of 5% of industries in the maintenance 4.0 industry, we will make it at least 60% by next 10 years. Okay, thank you, sir. Sir.
Thanks, Dr. Anup. I think before we invite the next speaker, right, I think I hope you have enjoyed the session, and we are looking to make this alumni expert series more and more intuitive, and also invite speakers across all spectrum of the industry. So alumni who would like to be involved in this webinar and talks, please reach out to the RCM staff, right? And we would like to have your inputs and also have you involved in organizing these talks as well. And now I would request Ms. Yafia, the final year mechanical engineering student, to deliver a note of thanks.
Yeah, thank you, sir. Good evening, everyone. On behalf of RCM and everyone who joined us today, I would like to sincerely thank Mr. Anup Saxena, sir, for taking the time to be with us and share his valuable insights. Sir, your session was such a better understanding of plant and equipment management, reliability, and the evolving role of maintenance 4.0 and industry 5.0. What I personally found really valuable was how you connected these concepts with the skills and career opportunities that engineers need to prepare for in the future. It was not just about the technical aspects, but also about understanding how we as young engineers can adapt to the changes happening in the industrial landscape. Thank you, sir, for such an insightful and engaging session. I'm sure everyone here has taken away something valuable from it. Once again, sir, thank you so much, and thank you everyone for joining us. Have a wonderful evening.
Thank you very much, all of you.
Yeah, thank you. Thank you.
Thank you, sir. Have a good day, a good evening.